What's up my Rust homies and welcome to another video. This is the second part of the video series about the concept of structs in Rust. For those of you who missed the first part, let's just make a quick recap. We said that structs are a way in Rust of grouping together properties related to a single semantic group. So for example, when you think about a car, you can think about its loose components like tires, the motor, the steering wheel and so on. But these pieces cannot do much alone. They have to work together. This is the same thing with structs. A single property on its own could give us little info, but it can be meaningful when enclosed in the right context. We have seen some example of struct declarations, for example the user struct, and this is basically a container for some properties that relate to a user, so its username, the email, whether the user is active currently or not, and the number of previously sign-ins. And so far we have talked about structs as some data containers, which is the what of the equation. But we also have some mechanism of data manipulation and interaction with an outside world, and this is the how of our equation. For this concept, we will change the struct example, so instead of a user struct, now we will have a child struct. Okay, we created the struct child, so this will be our baby factory. And then we can create our first child like this. So C will be a child named Carlos, I like that name, of age 4, whose favorite game is hide and seek. So how can we interact with this child? For example, we can define a function play that will take a reference to a child, which can be any child, and then it just prints this message. So, hey, child, let's play your favorite game. And this will be c.name and c.game. Now in the main function we call this function, so play, and we pass a reference to Carlos, and this will compile. So, hey Carlos, let's play hide and seek. Okay, that's nice. Now, let's say that we have another struct which refers to a concept of a dog. And instead of favorite game, we have all the other properties, but we have favorite food instead of game. And it's clear that we cannot use the same function to play with both a dog and a child, because they have different behaviors, they are two different semantic concepts. And so, of course, this is a silly example, but it gives you the idea. Because when you are building complex projects, it can happen that you decide to give the same name to different functions which are related to different concepts, like for example two different structs. In practice, we need a way to bind a function to a struct. And these types of special functions are called methods. We declare them with the fn keyword and the name, and unlike functions, methods are defined within the context of a struct, and their first parameter is always self, which represents the instance of the struct the method is being called on. So now we got rid of the external function play, and inside this context, this implement context, we created a method play, which is now bound to child. So everything within this implement block will be associated with the child type. And in the main function, you can note that where we called previously the play function and passed child as an argument, we can instead now use method syntax to call the play method on our child instance. So now it will be just c.play. The method syntax goes after an instance. We add the dot followed by the method name, the parentheses and any arguments. In the signature of the method play, self is just an alias for the type we are implementing methods on, which in this case is the child struct. Just as functions, methods can take ownership of self, borrow self immutably, as we've done here, or borrow self mutably, just as they can with any other parameter. Having a method that takes ownership of the instance by just using a self as the first parameter is really rare. This technique is usually used when the method transforms self into something else, and you want to prevent the caller from using the original instance after the transformation. So now you can see, that the script still compiles and have the behavior just as before. So we still have, hey Carlos, let's play hide and seek. Nice. One other important thing to mention is that besides creating methods instead of functions just for separation of concerns, as I explained before, another reason for using methods is organization. As you can see now, we put all the things we can do with an instance of a type in one implement block, rather than making future users of our code search for capabilities of child in various places scattered across all the library or across various files. Guys, I just want to mention another thing about methods, which can also be called associated functions, because sometimes there are associated functions that don't have self as their first parameter, and thus they are not properly methods, because they don't need an instance of the type to work with. We've already used one function like this, which is the string from, so this is how you can create a string from a string literal, and this is defined on the string type. Associated functions that aren't methods are often used for constructors, like the string from method. And these will return a new instance of the struct. These type of functions are often named new, but new is not a reserved name for Rust, so it's not built into the language. For example, we could choose to provide an associated function named baby that would have a name parameter and use that to create a newborn baby. So this will make it easier to create a creator rather than a father and a mother. So this is our baby factory. To call this associative function, we use the double colon syntax with the struct name. So here in the main we have, in the implementation block we have our new function, and this will not take a self argument as I've said before, but instead it will take a string parameter, which will be the name, and then it returns a self instance, because of course it creates a new instance of child. And this child will have the name that we passed to the function, then 0 age, and a game of choice, in this case too young for playing LOL. So we can test this in the main block. And so let's see, and this will be, as I said before, child. We use the namespace child and then double colon and then new, and we can pass a name. Of course here we can use our fantasy, and I'll go with Carlos Jr. Okay, cool. Let's test this out. So println welcome, and then the name, which of course is c.name, and this should compile right. Okay, nice. Welcome, Carlos Jr. Okay, just to recap, we've seen the main features of Structs, and guys, these could seem like simple things, but we are building blocks step by step, and now you should be pretty autonomous and you can start building serious things. So, my Rust homies, thank you for staying with me, and see you on the next video.